Hey guys, Mr. Milton here. Today we're going to solve inequalities number 2. At the end of this video, you should be able to solve inequalities with variables on both sides. Okay, so just like solving other inequalities, we solve inequalities with variables on both sides of the inequality the same as we would with equations. So we're really just going through some problems here. Follow along, try them out on your own. We have 5x minus 4 is less than 3x plus 8. Okay, we want to get our variables positive and on the same side, so I'm going to subtract 3x from both sides. Gives me 2x minus 4 is less than 8. Add 4 to both sides. I have 2x is greater or less than 12, and then divide by 2. I end up with x is less than 6. So there we have it. Graphing this, I'm going to use an open circle, going to less than this way. All right, number 2. 2 times the quantity x minus 5 is greater than 5x plus 11. My first step here, I'm going to distribute. So I have 2x minus 10 is greater than or equal to 5x plus 11. I'm going to get my x is positive, so I'll subtract 2x from both sides. And so that gives me negative 10 is greater than or equal to 3x plus 11. I'll subtract 11 from both sides. I get negative 21 is greater than or equal to 3x. Then I'll divide both those by 3. And so I'll have negative 7 is greater than or equal to x. Okay, when I write, I like to put my variable first. I want to make x is pointing to my variable, so I'll make sure it keeps pointing to my variable. Okay, and you'll notice that even though there's negative, we didn't have to flip the sign, remember, because we only flip the sign if we multiply or divide by a negative number. We divided by 3, which is positive, so we do not have to flip that sign. So negative 7, it's a closed circle there, going to the less than, be this way. All right, a couple more problems. We've got 6 plus 4 times the quantity x minus 3 is less than or equal to 9x minus 16. Okay, I'm going to distribute this 4 on this side and try to simplify this side down a little bit. So I have 6 plus 4x minus 12. Right side doesn't change. Combining my like terms here, that gives me 6 minus 12, negative 6. So I have 4x minus 6 is less than or equal to 9x minus 16. I'm going to get my x positive, so I'm going to subtract 4x from both sides. 5x minus 16 is greater than or equal to negative 6. I'm going to add 16 to both sides. So I have 10 here. 10 is less than or equal to 5x. Divide by 5. And so that gives me 2x. So I finish off with x is greater than or equal to 2. So at 2, it's going to be a closed circle, shade to the right. All right, number 4. We have x minus 1 over 6 is greater than 2x minus 4 over 9. So I'm going to cross multiply. It's important that I keep my numerators where they are. Multiplying this side by 9. Okay, my sign was like this. Multiplying this side by 6. Okay, with proportions we cross multiply. Okay, just important to stay organized and keep your numerators where they on the sides they are, and the inequality sign the same way, right? Unless we're multiplying or divided by a negative number, which we won't have to do in this case. So now as I distribute, I have 9x minus 9 is greater than 12x plus 24. Or nope, it's minus 24. And that is the importance of being organized. 12x minus 24. All right. So now we're solving it, variable on both sides. I'll subtract 9x from both sides. That gives me 3x. I'll add 24 to both sides. That gives me 15. I'll divide by 3 on both sides, and so I get 3. Oh, nope, did that wrong. So I'll get x, all right? And I write my variable in front. It's pointing to my variable. I'll make sure it continues to point to my variable. So x is less than 5. At 5, we'd have an open circle and shading to the left. Okay, so our rules don't change. They're all the same. You'll notice that in this case, I did not have to do anything where I multiplied or divided by a negative number. And that was all because of how I approach variables on both sides. Because we wanted to move it so that our x stayed positive, we did not have to worry about dividing by a negative number to get x by itself. Okay, so there we have it. Variables on both sides. If you can do that with equations, you can do it with inequalities.